In this video, we will see Enqueue operation in detail, and by using that logic, we will also learn how to write pseudocode for Enqueue. What is Enqueue? It is nothing but insert an element to the queue. Queue operates on first in first out principle, means that first element added to the queue will be the first one to be removed. Items can be inserted in a queue by using rear pointer. This is a circular queue. Imagine after few insertions and deletions, this is the current condition of queue. So, can you guess how many numbers present and what is the sequence? You got it. Total 4 elements, and first element is 15 and last element is 30. This is how it will look in a circular way. Let's see what we need for pseudocode to insert new element. First, we should know what variables and data structures we are going to use to build this logic. Here we will represent our queue by using an array of integer data type. Front variable stores the index of first element and rear variable stores the index of last element. Both are of integer data type. Max variable stores the maximum size of array, and queue length variable stores total number of elements present in the queue. Let's write pseudocode statements step by step to declare these variables. Declare queue as an array of integer data type, and then declare all the variables which we have discussed, like front, rear, max, queue length as an integer. What are the next steps of pseudocode? Before that, let's understand this. This is the initial stage of the queue. Initially, queue is empty, and that's the reason front and rear both pointers are having index 0. Queue length is also 0 because no elements present in the queue. Max is 5 means maximum 5 elements we can store in this queue. So next pseudocode statements are to initialize the values to the variables. Front, rear and queue length are 0 and max size is 5. All the variables are declared and initialized. Now let's see how to perform enqueue operation. Before going ahead with the next steps of pseudocode, we should understand some cases when we can perform enqueue and when we cannot perform enqueue. Can we perform insertion operation on this queue? Yes, we can, because front and rear are 0, means queue is empty. Queue length is 0, which is less than max size. If queue length is less than max, then it shows there is some space and we can add new element to the queue. This logic we can use to write pseudocode. Look at this queue. This is full because queue length is 5, which is equal to the max size. This means we cannot add new element to the queue. So the logic is, if queue length is less than max, then only we can perform enqueue. Otherwise it is full and no space to insert an element. Let's write the next steps for pseudocode. As we have seen, if queue length is less than max, then only we can perform enqueue, as display overflow message that queue is full. This is just the outer layer to decide when to add and when to display overflow message. At the place of dotted lines, later we will write the steps to insert new element. Let's understand this logic before to continue with pseudocode steps. Imagine queue is empty. Queue length is less than max. As queue is empty means front and rear are 0. The element which we will insert is the first element to be inserted. So front and rear both will point to index 1 and element 5 gets stored there. Now we got few steps to replace dotted lines. If queue length is 0 means if queue is empty, then front and rear both points to index 1. Easy, right? Likewise, we have to consider all the cases. What if the current condition of queue is this? Front is 1, rear is 3 and queue length is 3. which is less than max. So we can insert element in this queue. We can do this by just incrementing rear by 1. No change in front as it points to the first element. Let's write the statements for what we have discussed so far. First, we checked if there is any space by checking queue length is less than max. If yes, then we checked is queue empty. If yes, then we assigned front and rear both to 1. And we just saw if there is a space and queue is not empty, means if rear is less than max, then increment rear by 1. Pseudocode is not done yet. We have to consider all the cases. What if the current condition of queue is this? Front is 3, rear is 5 and queue length is 3, which is less than max. So we can insert element in this queue. Here we cannot increment rear, right? Rear is equal to the max. If rear is less than max, then only we can increment rear and not in this case. So what do we do? It's easy. Just point it back to index 1. These statements simply go in the else part. And finally, after considering all the cases before insertion, we have statements to find out the correct place for new element. We have focused on to find out new rear index because insertion happens at rear in the queue. Now we will see how actually to insert an element at new rear index. Rear is nothing but some index value. While declaring array, we have given name queue to the array. So simply assign the new value as a variable or directly a number to the queue array at rear index. You can put this entire code in a loop to insert multiple values. Let's write again all the pseudocode statements step by step which we have discussed for Enqueue. Declare queue as an array of integer type and then declare all the variables which we need. Assign the initial values to the variables. Check if queue length is less than max. If no, then display message queue is full. And if yes, then only we can insert an element. Let's find out new rear to insert new element. If queue length is 0, means this will be the first element, so front and rear both will be 1. Otherwise, if there are few elements and rear is less than max, then just increment rear by 1. Else, point rear to 1. We got new rear index. Simply assign the value to the new rear index of queue. Do you want to add multiple values? Just put this entire code in for loop and you are done.